Okay, we are live.
Thank you, Ben. Hi, everybody. I see everybody is kind of coming into the meeting today, and we're a couple minutes out from our starting, but I just wanted to welcome you to the August meeting of the Resource Planning Advisory Group for Puget Sound Energy. So just give us a couple more minutes and we will get started. For those of you just joining, I just wanted to welcome you to the August meeting of the Resource Planning Advisory Group for Puget Sound Energy. We'll get started in just a minute. I'm going to let a few more folks join us and then we will get going. All right, I think we're going to go ahead and get started. Thank you everybody so much for joining us today. This is the August meeting of PSE's Resource Planning Advisory Group. Welcome to RPAG members. Welcome to other participants. Welcome to PSE staff. It's going to be a great meeting today. I'm Hillary Wilkinson. I'm the facilitator of today's meeting. I'm with Mal Foster and Alongi. I'm a neutral third-party facilitator. I wanted to welcome all the RPAG members today and invite you to please introduce yourselves in the chat. And please remember to click everyone as you're introducing yourself in the chat so that everyone in today's session can see who you are and engage with you that way. My colleague Sam has posted the agenda for today's meeting in the chat, so please go there, and if you don't have the agenda in front of you, it'll be very helpful to have that. Also, I wanted to note that later in the meeting, Sam will share a poll that will allow you to give feedback on today's meeting, as well as any outstanding questions. I'm going to quickly walk through some introductory slides before we dive into the content today. Let's go ahead and go to the next slide. So first of all, we really want to have as much engagement with folks as possible. So please use the React feature to raise your hand or respond to content with emojis. RPAG members and PSE staff are welcome to use the chat feature, and the show captions feature allows you to see real-time closed captioning. Next slide, please. Again, my role as facilitator is to kind of be neutral and third party, and also to make sure we have a productive, constructive, and respectful meeting today. So in order to do that, I have a few requests. I'm going to go through them quickly. Just ask that you engage constructively and courteously towards all participants, respect the process that I've designed to guide us through this. Please spell out acronyms, explain technical questions. Please use PSE's feedback form or email address here. Please try to stay on the webinar topics today. That'll really help us achieve our objectives. And these last two are more, not so much requests as reminders that there will be a public comment period after all of PSE's presentations. And again, just really, really critical for those of you that are using the chat feature to please click the everyone option so that everyone in the webinar can see the content there. Let's see, next slide, please. We always do a safety moment, and today, appropriately, it's on wildfire smoke safety. So a few quick things. Check your local air quality at the airnow.gov. If you don't have it already, it's a great app and a good website. Reduce your exposure to wildfire smoke by staying indoors when possible and avoid running or exercising outdoors. Use high-efficiency air filters in your central AC system, or make a do-it-yourself air cleaner with a box fan and air filter. And lastly, wear a tightly fitting respirator mask if air conditions are poor and you must go outside. Next slide, please. These are all our presenters today. I'm not going to go through them right this second, but we will be introducing them as they come on screen. And most of you are probably familiar with everyone here, but we'll reintroduce folks just to be sure. Next slide, please. We have a lot of things we want to get through today, as usual. There's a lot of topics. This is also in your agenda. I just wanted to do a really quick scan. Kara Durbin is going to start with a quick work plan update. Steve's going to cover emerging technology assumptions and methodology. Go on to electric supply, emerging technology. Anyway, I'm going to let you all read the rest, but I just kind of want to give you a flavor of what we're covering today. And I encourage you to look at the agenda that was sent out, as well as is in the chat, and look at the objectives for today's meetings, because essentially what we're trying to get through today is make sure that we could discuss emerging technology assumptions, methodology, and sensitivity results, do a refresher on scenario development for the 2027 integrated system plan. We want to discuss the gas results for customer programs, delivery system and supply, and of course, provide an opportunity for public comment. The meeting is 4 hours. Sorry. The meeting ends at 4. The meeting is 3 hours long. I just wanted to make sure everybody knows that. There may have been a miscommunication on that. So next slide, please. As always, we want to hear from you, our PAG members, in the bulk of the meeting. We want to hear your questions, your reflections, get any advice on our topics, let us know if something's missing or unclear, flag areas for deeper discussion that we might bring forward to a future meeting, and help us identify risks and tensions. The way that we invite questions and comments is ideally waiting till the end of the presenter, just to give that presenter an opportunity to really get through their material. But if there is something really critical to understanding the content in the moment, feel free to raise your hand and we'll try to get to you. My job as facilitator is to make sure everyone has as much opportunity to engage as possible with questions and comments. So just please be patient with me as I try to make sure everyone has a chance to do that. And I have a phrase which is take space, make space. We want to hear from you, but we will also want everybody to be aware there's a lot of other folks with interest in this topic. So please make space for them. Okay, next slide, please. Critical questions before we dive in? Checking out the chat. Okay, not seeing any. I'm going to go ahead and hand it off to our first presenter, Kara Durbin, who you all know and have heard from before, the Director of Clean Energy Strategy at PSE. She's going to give a super brief update on the work plan. So Kara?
Thanks, Hillary. If you can go to the next slide. Thanks, everyone, for joining us. We're already at the end of August and looking ahead towards the remainder of the year. So, as we head into the fall, we thought it would just be worth taking a couple minutes to revisit what we think engagement over the next few months looks like as we march towards developing our draft ISP. So what you have in this slide at a high level is really outlining what we think some of the sequencing and topics look like for the RPAG, but also what we're considering for the other advisory groups that we engage with, the EAG and the CRAG. As we continue to go over results, revisit the cost test, review the decision framework, and really how that all comes together to inform the development of a draft portfolio. So today, as you know, and as Hillary outlined with our ambitious agenda, we're beginning to dive into some of the results, focusing today on the gas scenarios, the gas delivery system, and some of the electric sensitivities we've run so far on emerging technologies. And then we'll continue sharing results in the September RPAG meeting, kind of similar to how we took 2 meetings in kind of going over the reference case. We're starting with some of the results today, and then we'll continue sharing more results in September. In September, diving into the electric scenario results and also stepping back a little bit and looking at the electric and gas results together. And then as we move into October and November, we'll be working with you on portfolio development. This will include revisiting the cost test that we talked about some of the elements earlier this year and what our thinking is looking like there, the decision framework, and applying those at that portfolio level to help inform one or more draft portfolios. We will also revisit aspects of CETA, of the Clean Energy Transformation Act, what we previously included in a CEIP, which are required as components of this ISP. And so that includes talking about targets and goals, specific actions, and the equitable distribution of benefits. Those are some examples of things that we've talked about in a CIP context that we will be bringing forward to you later this fall as part of the ISP discussion. Our goal is to produce a draft ISP summary by early December. And what we hope to accomplish there is to outline the proposed portfolio or portfolios, the associated specific actions, and really the other major content areas or requirements of the plan as best we can, acknowledging where we are at with the conversation with you all and the materials we have as we get towards December. Our goal is to share as much as we can about what that draft may look like, with the goal of seeking feedback from you and from other advisory group members and the public. And so you see that a comment period listed near the end of the year. Again, we're aiming to produce that summary in early December and then be taking feedback throughout December and into January. Our hope is or our expectation is to go over that draft summary in our December meeting, give you all some time to digest. And then what you see in January is a potential drop-in session where you can bring any clarifying questions you have for the team as you're reviewing the draft and as you're thinking about what written feedback you might have for PSE on the draft plan. And then with the remaining couple months before we file the plan on April 1st, we don't anticipate we'll be meeting with you all as we have been really since 2025. We'll be working hard behind the scenes to digest the feedback you gave us, we'll be writing the full narrative, right? We're going to prepare a summary in December, but we'll be finishing the plan and considering what updates or changes we can make based on your feedback get all that pulled together and file the plan on time. So that's just a very quick high level view of what we see engagement looking like with you over the next several months. It's similar, but of course a little bit different than the work plan we filed, gosh, I think in December of last year. We've marched forward in time, right? And we have a little better sense of what the next remaining few months look like. So we wanted to bring this back to you all. We will file an update to our work plan in the commission's docket sometime in the next couple of weeks, so that's available publicly. It'll formalize what you see here. And so again, it's similar to what we filed previously, but with some adjustments of where we think the topics are landing with the remaining time we have. I think there is some comment in the chat about the feedback report, which was something I was going to bring up, and it may have already gotten covered. Hillary, I can touch on it too, if that's helpful, but I think I see Ray may have responded to a question about that already.
Yeah, Ray
Coming
responded, but Kara, I mean, feel free to reinforce it if you'd like to.
Yeah, the feedback report is coming soon. We always aim to finish the feedback report before our next meeting. Sometimes that timing works out. Sometimes we need a little more time. So we're really close. We're hoping to get it out either later today or tomorrow. And hopefully, and then you'll have that. So thanks for the question. Hillary, I think that's it from me on the work plan. I'm happy to take any questions if there are now, or if they come up later, that's fine too.
That sounds great, Kara. Thank you for that overview. So we have time for a couple minutes of questions on this engagement work plan that Kara just provided before we launch into the next topic. If you have a question about it, feel free to raise a virtual hand or a real hand, or post in the chat for RPAG members. Don't think I'm seeing any questions, Kara. Just going to give it about 10 more seconds. Sometimes it takes folks a minute. Yeah, okay. It sounds like there's no more questions. So with that, I'm going to go ahead and pivot us to our next agenda topic, which also has Kara leading us. So you just met Kara. The next topic is emerging technology assumptions and methodology. Kara's going to kick it off and then hand it over to Steve Schuneman, who is the manager of emerging technology and sustainability at PSE. So I'll hand it back to you, Kara.
Thank you. Thanks, Hillary. Yeah, I'm just going to briefly set the stage here. You really want to hear from Steve and Elizabeth, not me, but I just want to acknowledge that given all the dialogue and the comments that we've been receiving around our emerging technology assumptions and how they influence the reference case, we just really thought it'd be worth revisiting those assumptions in a little more detail here today. And so that's really the purpose of this. Steve will take some time to dive into the details a little bit more and take any questions you may have, and then we'll transition over to Elizabeth to go over a number of different sensitivities that we've run so far that really test different assumptions around emerging technologies, costs, availability. Several of those we came up with based on the questions and feedback we've been hearing from you coming around conversations we had since we shared the reference case. So our goal today is really to leave with a shared understanding of how PSE evaluated emerging tech in its analysis, and that it's important to remember that for many of these technologies, we're assuming that they won't be available to us in the portfolio until much later in the planning period. So practically speaking, this means that if these technologies mature much faster or slower than we estimate in this plan, it's important to remember that we'll have an opportunity when we develop the next ISP, the 2030 ISP. I know 2030 sounds far away, but we'll be kicking off that cycle before you know it. And so it will give us a chance to take a closer look at all of those assumptions and make adjustments to the next portfolio based on the best estimates and information that we have then. And we will be going through another round of engagement and input from you. So I just wanted to underscore that these are our best estimates. We want to talk to you some more about how we arrived at them, but we also are going to have a chance to revisit this as we move forward in time and see how emerging technologies truly do emerge. We have feedback questions for you at the end of this section. I do want to tee them up quickly now so you can think about them as Steve and Elizabeth walk through their information. We really want to know if the emerging technology sensitivities, and Elizabeth will go through those, the ones that we've run so far, are they capturing your feedback in terms of aspects that you wanted to understand better or test different assumptions? And if they're not, we really want to hear what you think is missing. So is there an emerging tech assumption or a combination of assumptions looked at together that we really need to look at and understand to help us inform development of the preferred portfolio? So that is our one of our main asks of you, is to think about that and give us feedback when we get there. And of course, if you have other questions or observations, please, we welcome them along the way, but that's part of what we're hoping to do today. I think if you could go the next slide, or maybe even the next one. I might have just been talking the title slide, but that's fine. I covered those objectives. We're all good. The next one just lists the engagement that we've been on around emerging tech. It's really just for your reference. We've been talking about this since, gosh, October 2024 RPAG meeting, and then have revisited this a number of times with you all. I would point out the feedback memo that we shared with you back in October might be particularly useful just as a reference point. So without that, that's all from me. I think I'd really like to turn it over to Steve now, and we'll walk through the materials in this section. Thank you. Steve, take it away.
All right. Thank you, Kara. All right. Next slide, please. Okay, as Karen noted, we are going to spend the next several slides over the next 10 to 15 minutes discussing how we treat emerging technology, how we view the emerging technology landscape, and then how those assumptions are incorporated into the ISP modeling process. So from a broad overview perspective, steps 1, 2, and 3 are really how we are engaging with the emerging technology space today. So when we start out by monitoring, this is monitoring lots of different areas of development, including what's going on with specific developers, what's going on in national laboratories, perhaps what's going on with university R&D, and trying to get a sense for where the fundamental research and development is going. So that will inform future decisions about sort of where these technologies are going, and then maybe at a broad view, are they applicable to what we are doing as a utility, and when we should start to pay more attention. The assessment phase, that's when they start to become a little bit more mature and a little bit more concrete projections. Maybe things are moving from a benchtop scale over into, sorry, I'm hearing a difficulty here. I'll speak up. Move into how we assess and then can incorporate them into our planning models. So things that could be example of assessments could be like ramp rates, could be min and max. Are things, do they have peak generating capacities, or are they more of a base load perspective? Those are the characteristics that we try to understand. And then when we get down into the modeling, that is when we've got enough concrete information to be able to build a portfolio around some of these emerging technologies. So this is when there is a first, call it an initial deployment, whether it's a pilot scale or perhaps there's enough concrete information that we're able to have a confidence that the numbers that we are getting are realistic. Once we build an ISP model with emerging tech, and when we establish that that is the preferred portfolio, it goes into an acquisition process. So this would typically be an RFP-based stance, whether we're looking for a specific technology such as a geothermal or maybe a carbon capture solution, as well as the ability to incorporate into an all-source RFP. So when we talk about mature technologies, I want to provide a little bit more clarity around what we mean by that. So number one, this is proven at utility scale. So utility scale is generally 5 megawatts and above. So something that is a considerable investment and real a durable infrastructure. Something that has at least an initial track record of providing credible cost and performance data, and including attributes that can be independently verified and not just developer claims. Next, we look at the supply chain and try to ascertain, is this going to be a resource that is scalable and one that is durable over the long term? And then lastly, we look at the path to interconnect, which would be true for almost any resource, understanding what the interconnection solution looks like, whether it is going to face the same challenges as other resources, or perhaps maybe find something a little bit better. Next slide, please.
Hey, Steve, I'm sorry to interrupt you. People are still having a little bit of a hard time hearing you. So I'm wondering if you can either get closer to your mic, but also for those online, Sam has posted a little instruction on maybe how to get the volume up on your end. So just for your awareness, Steve, people might need to
Yeah,
turn up the volume.
yeah, I
Thank
see that,
you.
see that in the notes. I'm fairly close to my computer here now, so let me try one thing real quick. Okay, we'll see if that helps a little bit here.
Thank
And
you,
Steve,
Steve.
using a similar process to what I described, you can check to make sure your input volume is high enough because your input volume may be low. So if you go to the microphone, hit the caret, go to audio settings, and just double
Sam,
check to see your
Sam,
input
I'm going to
volume.
interrupt you. You're echoing, so I think you might have two mics on. All right, Steve, carry on.
Okay. Okay, let's talk about the technology readiness level. This is a scale that we use to evaluate how emerging technologies are developing. This is an adaptation of the NASA technology readiness scale that was developed for the Apollo space program. It has since been adapted for use in many different industries, including the energy industry. We generally, it's easiest to look at this in three different phases. So TRL 1 through 3 are really the early stage inventors. These are brand new concepts. These are things that are in R&D capacities, research labs and universities. They are things that may have commercial value at some point in time, but they're really just an idea. And from a general time frame, that is a 2 to 5 year process. Moving into the 4 to 5 to 6 year range, this is when something goes from validation at a benchtop level over towards ultimately trying to develop a prototype in the field. This would be something of at least a significant enough scale that it validates that the underlying assumptions and the basic science it does actually work. Depending on the size of the effort and the size and the type of technology, this can range anywhere from 5 to 9 years. TRL 6, if you've spent any time in this, is oftentimes known as the Valley of Death. This is when between 5 and 7, a lot of demonstration projects are really in the early funding phases and trying to get through from a prototype and from an early pilot phase and working with investors to get towards commercial scale is one of the more challenging parts of early stage development. Once it gets into 7 to 9, that's when we start to really pay attention and we start to get the information that enables us to build build the analytics in the ISP such that we're able to make informed decisions about the modeling itself. So TRL 7 is going to be your initial full scale field deployment in the field. So to make a tangible example out of that, I'd classify Fervo with their Cape Station project right about TRL 7 right now as they're building that out. A lot of the small modular reactors are somewhere between that 5 to 6 to 7 range as well. You could argue TerraPower is maybe right in that 7 level as well. So from the resource modeling, where it sits in the scale, again, 6 to 7 gives us information of a prototype in an operational environment. TRL 8's when systems are completed and qualified. And then really when you get to 9, multiple deployments are out in the field. They can be independently verified. Perhaps there is more than one vendor in a specific technology space. And that is really when we're starting to move from a studying and modeling standpoint into an acquisition standpoint. I see a hand up. Dan?
Yeah, Steve, sorry, Dan, go ahead. I also wanted to flag for you, Steve. We have a couple more questions in the chat. So after Dan's
Okay.
question, we'll pivot to the chat.
Yeah, I put my question in the chat. Good to see you, Steve. Thanks
Mhm.
for taking my question. My question was, you made a point on a previous slide of identifying what a mature resource is. And I was just curious, I think you might have just answered it, where it enters in, where a mature resource actually enters into the planning process. And now on this slide, where I might slot mature technology in your technology readiness level scale.
So a mature technology is going to be a TRL 9. almost by definition. So if you look at wind and solar and BESS systems, particularly lithium ion, those would all be TRL 9. So those would not be considered emerging technologies.
Thanks for that question, Dan, and your response, Steve. A couple more quick questions. One from JP, where can we find the criteria that B&V uses to classify resources in these different TRL levels?
That they use the same scale. I think I would wait for I'll ask Elizabeth to clarify that one on the B&V report. I think originally that came out to hers.
Okay, thanks for that. So JP, Elizabeth will hopefully address that later. And then last question in the chat that I'm seeing from Dennis with regard to a 9 to 18 year window. What do you have under your control to speed up the cycle?
As a utility, as a direct investment vehicle, not a whole lot. That is not really our place as Puget Sound Energy to invest in emerging technologies and use ratepayer funds. That's generally not how the business model is built, particularly around our requirements for procuring mature technologies, as well as our commission's thoughts on what is appropriate for PSE to be doing. What we can do, though, is indicate market demand. So, and that is a lot of what we do when we do talk to these developers, is educate them on what our needs are and the urgency of our needs. Things like an MOU with an early stage developer, whether it's Fusion or someone else like that, oftentimes can help them get financing, which can help speed up the cycle. So indicating market demand is something that we can do, but in terms of direct investment, we have some more limited tools at our disposal.
All right, thank you, Steve. Thank you, everybody, for those great questions. Steve, I'm going to let you continue, and then if people could, there will be another chance to ask Steve questions, but let's let him get through a little bit more of his presentation.
Sounds good. Let's go next slide, please. Okay, so let's take a deep dive into why long duration storage is modeled as available in 2035. So looking at how Form and their iron air battery system has come to market, I mean, I'm not sure the exact date they were incorporated, but it's relatively recently. It's certainly within the last 5 or 6 years or so. So looking at them from a early stage development perspective, some of their first initial pilot work was in that 2023, 2024, 2025 timeframe. That's when we started to get information that would enable us to start to do the modeling. Some of their first pilots were operational really earlier this year. And then their Excel project, their 100 megawatt, 100-hour project with Excel, that's kicking off this year, ideally with completion towards the later in the 2028, maybe the 2030 timeframe. So why 2030? All emerging technology in the ISP is modeled with a 5-year development lead time that is consistent with numerous other energies that we procure from the minute that you got final investment decision and then you're able to start moving forward. It generally takes about 5 years. So that's not to say that the technology itself would be ready in 2035. That's the first time that it would be probably operational in our system. So just want to make that distinction. And again, I think later on, Elizabeth will be able to speak to sort of some of the timelines around this. So looking at what it takes to bring a PSE project scale online, again, getting something into those 7-8 range, that's probably the earliest that we could probably start to engage and maybe discuss a pilot project. Pilot projects are something that we can do, but we've also found that pilot projects can be fairly expensive and a questionable use of ratepayer resources. So sometimes they work for us and sometimes they don't. From a supply and delivery queue perspective, we also take a look at where those development pipelines look like from an order stand book perspective, if there's availability for us, or is the order book being closed out for the foreseeable future. And then how do we engage with either an alternate developer or work with an existing developer on maybe some increased production capacity. So I understand there's another question here. Is PSE considering filling a long duration storage pilot? We did look at conducting a long range storage pilot with Form approximately 4 years ago. There were some challenges around siting and around some of the interconnect agreements that we were trying to develop with that. That was a 10 megawatt project. By the time that we were able to find a suitable site, Form itself had moved on and was not doing pilot projects anymore, and they had moved into a commercial development project or commercial development pipeline. The other challenge again was really questions and challenges around cost prudency. It was not a cheap project. It was quite expensive actually for what it was, and that put a little bit of a challenge around what on how it would meet some prudency standards. Okay, next slide, please. Okay, so looking at some technologies that how we model them and what first years are available, the top half of the chart are the TRL9. So these are all commercially mature, available energy systems that we can go out and procure today. So no reason to put them in the TRL9, or I'm sorry, in the emerging tech bucket. These are all commercially available. First year available from a 2031 perspective. Again, backtrack out a 5-year development cycle, that would mean everything, if we made a decision today, 2031 would be when they come online. Looking a little bit farther down into the emerging technology bucket, some of these other technologies, again, they're in that 7 to 9 range where we can start to think about, getting more accurate modeling and then getting into a procurement standpoint. Compressed air, again, that's actually been done before, so that would be more a matter of site investigation, site procurement, and then development. Looking at geothermal and some of the costs around geothermal, later in the deck, we'll talk about specifically about the cost. There's a lot of evidence out there that geothermal capital costs are about half that number, and we did run a sensitivity around that. So some of the latest information that we had from the ATB as well as the Black and Veatch report showed that as of a couple of years ago, they were still fairly expensive. Advancements in drilling technology and some of the efficiencies they've gained actually have driven the capital cost down quite a bit. And we believe that's trending in the right direction. So that's something that we're paying attention to, and we're going to spend more effort over the next coming months on how to get our hands around what a more accurate capital cost of geothermal might be. Next slide, please. Actually, we'll move to some questions here. Where the capital costs come from, capital cost, that is a cost per kilowatt. In general, from a mature technology perspective, there are numerous sources to gain capital costs. The National Lab of the Rockies Alternative Technology Baseline has been a good resource for a number of years. It has not been published in the last couple of years, and it is not clear whether it's going to be published moving forward. So we are searching for a replacement, and right now it's looking like it could be a combination of resources, or I'm sorry, sources itself. In talking to other utilities on how they get information around capital costs, a lot of people are, and a lot of groups are taking approach of averaging credible sources. So something like the Lazard report, looking at techno-economic modeling from other independent resources, and sort of signing a weight, if you will, to some of those, the credibility of the source itself, is something that we're working on.
I'll also hop in. Just to clarify some of our capital costs, we did cover this earlier in the year with our update. So some of the costs are coming from Black and Veatch. Some of the costs are coming from what was the 24 ATB. That was the last time that technology baseline was published. And some of the costs have been informed by current market conditions. And so that's really important as we have some of these mature technologies. We're seeing what's happening in the market and supplies. So we did do a pretty big update this last year to inform of what we're seeing of current market conditions. But as we know, what Steve noted, especially with geothermal, lots are changing as we try and narrow down some of the costs. Things are changing as we're moving along. Also, to cover on the costs, those costs are strictly just the capital cost for construction. It's called engineer, procure, construct. EPC costs is what it's noted as. It's also sometimes referred to as overnight costs in some reports if you're trying to look up these different kind of available information to compare some costs. And it's strictly just the cost to procure the items and construct the power plant. We will then go in later and layering in all the maintenance upkeep costs, fuel costs, transmission costs, interconnection costs. Those are all separate costs that get layered in. This is what you saw on the chart was purely just the capital cost for construction of the plants.
Thank you, Elizabeth. Very much appreciate that. A couple questions in the chat. Quinn, the TRLs definitely do advance in the model over time, just based on where the technologies are going and how the market is deploying them and testing them. The modeling, we can run sensitivities over time. That would be what, based on what I'm seeing and what others are seeing, Elizabeth's group can certainly run different sensitivities based on, TRL advancements and how the refinement of those performance metrics really come into view for us. Sodium ion batteries are somewhere in that 6-7 range. They are certainly, there's been some pilots. I believe there's a developer out of Oregon that's working on a sodium ion battery system. But those ones that, something like that is not particularly complicated from what we can tell. And so a sodium ion could go from a 7 to a 9 relatively quickly, depending on developer activity and procurement in the marketplace. Katie.
Thanks, Stephen.
Actually, sorry, Katie, can you hold that thought for just a second? I'm going to hop in here. I'm just doing a little bit of a time check. We're a little bit of overtime for Steve's segment. This is great information. Katie will take your question. Steve, I just wanted to make sure you had time to finish your material, or do you want to just drop into Q&A real quick?
Actually, yeah, we can just talk about this at I think this is the last slide before questions anyway. So the emerging technologies have different capacity factors, of different ELCCs based on different tranches. Geothermal and long duration iron ore both show up as having higher ELCCs. This is not particularly surprising. SMR as well is a very, those are meant to run as baseload applications. So I don't know that there's anything revolutionary about sort of where we're seeing the biggest ELCC values. Elizabeth can speak more intelligently about why we're putting them in the different tranches.
Yeah, so really the important part about the tranches is the saturation of the resources, in particular the energy limited resources such as energy storage. As we get more of those energy limited resources and the duration of events is increasing in magnitude, those resources have less and less availability during an event. So you see they start to drop off pretty drastically after the first tranche. These size of the tranches are different by each resource type, which is why we didn't put sizing on here. So you would see different sizes for each resource type, but they're falling off. And what's happening is the mid duration storage we're seeing is saturating very quickly with the short duration storage, given these longer duration events. So you can start mid duration starts at a little bit higher point, but by the time you move into the second tranche, you've saturated both the mid duration and short duration storage. Long duration storage does help quite a bit longer before it starts saturating, as I noted with these longer duration events. And so you see a little bit further time until the long duration storage starts saturating at a different point.
All right,
Okay.
thanks for hopping in there, Elizabeth. Steve, are you ready for us to hop to a couple questions that are hanging?
Just make sure last slide there. One more slide. I think
I
that's.
think that may have been
it.
the last slide. Yeah.
Okay.
So
Maybe-
Katie, thank you for your patience. Go ahead and hop on screen and come on audio.
Yeah, thanks. If you could go back to the previous slide, that's where I'll focus. The slide before this does go into costs that I think might be a little too low for the peaker, according to most recent analysis that I've seen, and we can provide that in feedback after this. But I want to ask a couple clarifying questions on this slide in particular. So short duration storage, as Elizabeth just went into, it sounds like short duration storage is meant to cover, is that just 4-hour lithium ion batteries?
Yeah, so we tested short duration at the shorter, that's the 2 to 6 hour range. Testing, we did, 3, 4 hour type batteries. And so that's what the short duration. The mid duration is covering the 8 to 24 hour range. We tested a couple different points within there too. And then you have the longer duration, which is the multi-day. It was a 100-hour battery, which we actually tested for the long duration storage.
Okay, so I do think that it would be helpful to see each of those different lithium-ion battery configurations separately because they have different saturation curves. And S&P Global released an analysis last week that showed that if you combine those three, the saturation of the ELCC is much less over time than if you were to focus on the same nameplate capacity with just 4-hour batteries, for example. So I know that that's something that we've commented on a lot. I do feel like throughout the slideshow here that it's unclear what short duration means. You just mentioned 2, 4, and 6. And in the information about reference case B and A, I guess it's unclear throughout the presentation what short duration storage means. So if throughout we could mention exactly what is considered under short and mid and maybe even long, that would be helpful.
Yeah, so I mean, if you're looking at kind of layering, you would have the short duration, which is about the 4 hours. So if you're looking at more an 8-hour battery, that would be the mid duration. So that's what we're trying to test is 8 and 10-hour batteries in there versus the 100 hours with the long duration.
Okay, and for the renewable peaker, is that with biodiesel?
Yes.
Okay.
And we included about 120 hours of storage backup on the fuel.
Katie, thank you
Thank you.
for those questions. So we're going to take 2 more questions for Steve, and then we're going to transition to the next segment just in the interest of time. I'm going to first pop to Dan's question in the chat, and then Quinn, I'm going to pivot to you. So Dan asks, is transmission available for Eastern Washington resources?
So the costs that we included in the previous slide do not include the transmission cost, but we do have the transmission costs, which were covered in a different RPAG. I'll have to get the date of the RPAG. So we did go through all the transmission costs from all the different zones. And in our May RPAG, we did do kind of all these levelized costs, and that was including all the transmission costs. So if you'll see solar and wind, that's from Eastern Washington, including all the transmission costs and interconnection costs from Eastern Washington. So when we finish up the work, we'll have a lot of different tables going through each of the different zones and how that pairs into the transmission costs and the resource costs for all the zones.
All right, thanks for that question, Dan, and your response, Elizabeth. Okay, Quinn, last question on this segment, and then we're going to move on. Go ahead.
Hey, Stephen. I'm just curious I know it's kind of a small difference, but what is the difference between the ELCC? Why is there a slight difference between the ELCCs for the gas peakers and the renewable peakers? Is it, yeah.
So what's happening is really the ELCCs are based off of forced outage rates and the availability. So it could be natural gas has a longer availability than the renewable peakers. Also, what's happening is the biofuel peakers has a higher heat content to burn the biofuel peaker. So, example, the exact same CT unit under natural gas has 120 megawatt capacity versus under biodiesel, it could have like a 100 megawatt capacity. So you're seeing quite a bit of reduction of capacity depending on the fuels you're using. It could be the exact same unit. It's just the heat content of the fuel has different aspects into how the nameplate and heat rates of the peaker unit.
Great, thanks for that question, Quinn, and your response, Elizabeth. We are going to continue on. Katie, I'm hoping your question could get answered in the chat. I want to make sure the rest of the presenters have a chance to present their material. Thank you very much, Steve, for your excellent presentation, and Kara. We are now going to pivot to Elizabeth, who is the manager for resource planning and analysis. She's going to cover this topic of electric supply, emerging technologies, sensitivities, results. I'm going to ask that people please hold your questions if you can until Elizabeth's presentation is done, just in the interest of time. So jot it down, and you can post it in the chat and we'll pivot to it. But Elizabeth, I'll manage the Q&A, so just feel free to focus on your presentation. Just take it away.
Great, thank you. As Hillary noted, I'll be going through some of the emerging technology sensitivities. If you want to go to the next slide, please. So what we're going to go through is we're just going to kind of cover where our base reference case started. And so it was just a starting point, and then all of the kind of changes we've been updating, feedback we've been receiving. And so thank you for all the feedback we received. Been trying to make adjustments as we receive feedback, and we've been putting together these different portfolios to help kind of cover what we've been hearing. If this doesn't cover everything, to let us know, and we're trying to make adjustments as we move along. Next slide, please. And so some of the feedback themes we've been hearing are costs of resources. In particular, geothermal came up as a question. So our starting capital cost did come from the 24 ATB report. We're kind of seeing more recent information, and we did receive feedback that geothermal costs we can see are coming down, as the 24 ATB report was a few years ago. And then by the time it gets into these reports, it's already a few years old, because they are kind of averages over several years and can get pretty dated. So we're seeing kind of more recent information. So we are running tests. We did run a test on lower geothermal costs. We did get questions about kind of looking at long duration energy storage versus mid duration storage, the 8-hour batteries versus the longer 100-hour batteries. And this was a lot in relation to kind of the gas plants. Received a lot of feedback around the magnitude of gas plants that ended up in that reference case. So we've built several different sensitivities around increasing long duration storage, or kind of isolating out storage, or we even asked the question of, what if we just did less peakers into the portfolio and letting the model optimize the different types of storage and emerging technologies to kind of backfill in those resources. So we kind of looked through several different of those options. These all kind of play together. We did a bunch of combined portfolios as well to see how things are interacting with each other as well. And so just some of the things to understand, as we noted, and as we're seeing costs can be coming down, a lot of things can happen pretty quickly. A lot of things can change. And some resources may not maintain momentum at the rates they have been. They may kind of stall at some point and then need to get going. So there's a lot of risks. And so that's why we're running kind of these sensitivities around the risks we can see with some of these emerging technologies. And so what we do know is the currently available technologies as of today, we're seeing what they're costing today. That's what we do know. Everything else, we're kind of making estimates and speculations of what may happen into the future. So this is really a lot where the sensitivity testing is coming in, to understand all these what if conditions. And so we know some of the risks that may be involved as well in moving forward with some of these technologies. I think next slide, please. Just to kind of go through where we're at with some of the information. This is kind of a little bit more detailed of the previous slide. I won't go through everything, but as noted, we went through a couple different iterations. What if we had no emerging tech? This was using just the TRL9 today resources. What if we started kind of bringing back a little bit of the emerging tech at a time, starting with long duration storage, because it's kind of right there at the edge, as we're seeing, it may become available within the next few years. Just also noting with timelines to get things available as well. Also looking at the cost curves of some of these resources and understanding how the costs can be changing. Um, and also looking at what if we didn't do as much of the flex fuel peakers, or removed all the flex fuel peakers altogether, to see how that will change the resources, not just the builds, but the cost of the portfolio. And we're just trying to get to relative differences and changes in builds and costs, to see where this might be taking us into the future, and just kind of understand where we might be going. I think next slide. So just to start out, we last met in May, just to go through what's happening with the reference case. And since then, just to note, we went with the reference case that included all the emerging technology with the costs and start dates that were previously noted on this slide 17. that was our starting point. And so with that in mind, we are now seeing emerging technology come into this portfolio, such as geothermal and nuclear coming out into the later years. They started coming into the portfolio around the 2040s, as we saw in this case. This also built in quite a bit of um, the flex fuel peakers, as we noted, and quite a bit of wind, solar, and storage for meeting the renewable CEDAR requirements. I think next slide. So building off of that was our starting point with the emerging technology. And so we started rebuilding different portfolios, these what if cases. This is kind of a big chart. I won't go through everything, but this is just going through how we looked at the different portfolios, where we're differing this from the reference case and we also noting layered in multiple of these cases together to get kind of these larger sensitivities. Like, okay, if we add 500 megawatts of long duration storage, but what if geothermal is also lower cost? So we started adding several together to kind of narrow in on how these things might be interacting with each other as well, to kind of get down to ideas. And so I think next slide. Also stop. I might have seen a question pop up, so I can stop briefly if there's questions.
Elizabeth, I'm going to suggest, because we're a little behind time, to keep going, and we'll
Okay.
take questions at the end of your presentation.
Okay, no, I can keep going. That's fine. So just looking at this slide, this is like a total builds by 2050. This is just the nameplate builds that we're looking at. This is not indication of peak contribution or energy contribution, just the nameplate builds. And so what we're seeing as we start moving through this, so for example, the reference case did have quite a bit of flex fuel peakers and short duration storage. We did have mid duration and long duration as options into this portfolio. They just didn't get chosen in the portfolio. It was part of the kind of low cost optimal portfolio. So we started layering in like, okay, what if we just forced in some more long duration storage? What's happening about how far out is it? So we pushed in the 500 megawatts of long duration storage. When we did that, we saw roughly 400 megawatts less of the flex fuel peakers to meet that same peak contribution and energy contributions. And then the next question came out like, okay, rather than trying to force in a specific type of resource, what if we just limited the flex fuel peakers? And so what we did with the builds on that one is, in the reference case, it was 5,000 megawatts builds by 2050. We just wanted a halfway point. And so we said, what if we limited to 2,500 megawatts? That was a nice halfway point. And it just wanted to get to the results to see what it did. And so when we did that, it let the model optimize. And what we're seeing in that is it kind of came to conclusions of more emerging technology, long duration storage, and nuclear coming into the portfolio to meet those capacity needs and some of the energy needs coming in as well. So that's why you're seeing kind of it optimized to a lower total nameplate add, as the nuclear resource does have a high capacity value. And it also has a lot of energy contribution. So it also offsets quite a bit of wind and solar for the portfolio for meeting the CEDAR requirements. And then we just started layering increases in from there. What if we removed all the flex fuel peakers? And you can see it added quite a bit of more of the long duration and the batteries and the solar, a lot of different resources to meet into those capacity needs. And so all the way up to increasing levels of resources as we tried to bring out, remove several of the different options into the portfolio. Overall, what we're seeing is if you try to remove the flex fuel peakers altogether, you get a significantly higher amount of builds to try and meet those capacity needs. If you're looking to more just limit the amount of builds, you can actually get kind of a little bit less nameplate. It comes at a little bit higher cost, which we'll see at the next portfolio as well. But you're going to have to weigh the types of resources to the costs as well. And this is also where we're getting into, we're not entirely sure how much everything is going to cost in the future. So there's a lot of paths this can go down. I think next slide. as I noted when we went through these different portfolios, so we have the reference case all the way on the right. The total cost, including social cost of carbon, is about $59.5 billion. That's the NPV, net present value, 2028 through 2050 is the years we're looking at. When you force in the long duration storage, that does increase portfolio costs by about $800 million total over that 20 plus year time frame. And then another one looking at when you just try to limit the flex fuel peakers. This is trying to optimize into different options for meeting those peakers. That does increase portfolio costs as well. So this is where we're going to have to weigh increases to costs versus what it is we're trying to accomplish with this portfolio and where we're trying to get to the final point. As noted, the reference case is the lowest cost options we're looking at. So it's trying to optimize into the lowest cost plan. Any adjustments we're making after that is just going to be increasing costs. Some of it a little bit more, some of it a lot more increases to costs over time. I think next slide. And so then we came into what if geothermal was lower cost? So we reran everything with a lower cost geothermal. So if you look at reference versus a lower cost geothermal only, it's the same portfolio or the same setup. We just reduced the cost of geothermal. And what we saw there is really this switch from nuclear to geothermal. So you got the cost to switch over. So it's really switching between these two emerging technologies, between nuclear and geothermal, is what's happening as you're moving around the costs. That's the biggest impact that we saw when we lowered the cost of geothermal. And then we layered in several of the other sensitivities where we did the lower geothermal cost plus increased long duration storage or limited flex fuel peakers as well, just to see how those layers together would then change portfolio builds and costs. I think next slide. This is looking at the overall costs. And so what we did is we went from the reference to the lower geothermal costs. And just by lowering geothermal costs, you got the switch from the nuclear to geothermal at the lower cost. That did decrease the portfolio. So now with this lower cost, we ended up with a $57 billion portfolio. And then from there, we started layering in these different updates with long duration storage and limited peakers. And so what you're going to do is like the next one over, which is where we added in the 500 megawatts of long duration storage that compares back to the $57.4 billion. So you're kind of moving your starting point over now with the lower geothermal cost to now $57.4 billion is now your comparison reference case for these sensitivities. I think next slide. Just overall, what I've been noting, mostly you do have your reference case is your lowest cost portfolio by lower geothermal costs. We did lower the cost of portfolio by over $2 billion, and that's just changing the cost of resources. So, and it did get the switch between nuclear and gas, but everything else beyond that, trying to force in less peakers or more batteries, it does increase your portfolio costs. So you're going to have to try and weigh between these resources we're looking at and the cost to achieve these types of resources. And then overall, kind of what you're trying to offset with these resources as well. I think next slide should be my last slide. Yes. So just as we note, if we've missed anything, do let us know. We're trying to capture the full range, or we're trying to capture what we're hearing in some of the feedback.
Thank you, Elizabeth. Okay, I'm hopping in and we have some questions. We have a little bit of a limitation on time. I'm going to start, Elizabeth, with one from Katie. We have a question about how you applied ELCCs to hybrid resources. We think this might be a complex answer, so we want to give you the opportunity to either address it here or maybe address it in the feedback report. What do you think?
It is a pretty complex answer because what you're now adding is like a solar plus a battery, and they can be additive together under certain conditions. So I will say we'll put it in the feedback report how the battery or how the hybrid ELCCs work, so we can put kind of a better table together.
Okay, that sounds great. So Katie, Elizabeth is going to go into it in more detail in the feedback report. So I'm just thank
That
you for
wasn't
your patience on that.
that wasn't my question though. I just don't
Oh,
see I don't see hybrids anywhere in this presentation, and that's surprising because it's at the top of the interconnection queue all across the US, so wondering where that is.
You are correct. So we did model hybrids, and it is a really hard. I will say most of the wind and solar and batteries are hybrid combinations. And we had to weigh making these charts super complicated to try and call out the hybrids and how to best to look at hybrids. So we do actually see quite a bit of, we did model several hybrid options, a hybrid and battery, or like a wind and battery, solar and battery, a solar wind and battery. So these larger complex hybrid situations. Um, they're all in the models, and the model did actually choose a lot of those resources. And we do have the ELCC, so I can include the ELCCs in the feedback report. And if it'll help, we can try and do the breakdown of all these builds, looking at standalone versus all the hybrids are coming in, which is actually quite a bit of what we're seeing with the wind and solar and batteries coming in as well.
thanks, Elizabeth. A couple of questions from the chat, and then we're going to move to the next topic. And I think there's going to be a robust feedback report, and we're going to do our best to get to everybody's questions, but I suspect we may not have enough time for all of them. But a question from Dennis, does SCGHG cost increase as the time goes on based upon the feedback loop effect?
So the social cost of greenhouse gas, we have the starting point, which was established on the UTC website. So that's our starting point, and then we include inflation going forward beyond that. So we did include, I think it was in the appendix slides from our May meeting, um, our CCA costs over time and the social cost of carbon costs are on those same charts, and they do increase quite a bit over time as we see inflation coming in.
Great, thank you, Elizabeth. One last question, which is whether geothermal resources are assumed to be available in the Washington, Oregon, Idaho area.
Yeah, so we've put geothermal into Nevada and Oregon. There's also Idaho options too, though our configuration right now in the reference case is a very limited out of Idaho transmission. Most of the availability will be in kind of the Oregon zone. So that's really where we're putting the geothermal right now. I think you're muted, Hillary. Hillary, are you still muted or is it me?
Sorry, thank you, Elizabeth. You know it's going to happen once a meeting that I'm going to forget to unmute myself. I was just saying, thank you everybody for your patience as we kind of pivot between hands in the chat. In the interest of time, we're going to move on. I know there's more questions than we can address. They will get addressed in the feedback report. I do, and also PSE staff are working to address them in the chat. So if your question didn't get answered, we'll try to get it addressed in the chat here. These two questions that Elizabeth posted on the screen, I think are also important to get feedback on in the feedback report. So I'll work with PSE to make sure these are put forward as you respond there. So with that, Elizabeth, thank you very much for that presentation. Thanks for all the great questions. We're going to move on to Jen Colson, who's the Director of Resource Planning Analytics at PSE. She's going to speak to the scenario, or she's going to give a refresher on the scenario analysis. So if you could, Jack, if you could move the slides forward a couple. There we go. And Jen.
Yep, I'm here.
There she is. Okay, handing it over to you.
Okay, so I'm going to give a quick refresher and overview of the scenarios that we established with the RPAG about a year and a half ago now. And then we're going to dive into the gas supply results today, and we're going to talk about the electric results in September because it's a lot of information. So we can go to the next slide. The purpose of the session is to inform the RPAG on the scenario analysis that we're going to share today and in September as well. So we're really looking for feedback, clarifying questions regarding these results to help us better shape and understand the results that were presented. And we're looking for feedback. If there's opportunities, we will attempt to address the feedback in the analysis or maybe add a sensitivity analysis to better answer a question or a thought that you guys may have. So we can go on to the next slide. Today, again, we're going to focus on the gas utility side. So that's on the left-hand side of the screen with the customer supply, transmission, and distribution results. In September, we'll talk about the same components, but for the electric utility. And then we'll also work to look at the results holistically as well, because one challenge with looking at it this way is you're not seeing the impacts on the electric system at the same time. So we'll want to reflect that in September as well. Go to the next slide. So just some background on where we've been, because it's been a while. We kind of finalized these scenarios back at the end of 2024, and the scenarios were built with the intention of setting up not a precise future per se, but really frame up a varying potential and opportunities and these bookends where we could determine over various pathways how may we end up in one world versus another, and wanted to try to work on aligning those bookends with some realistic and actionable near-term goals as we build into those portfolios based on those results. And to do that, we were really working across all the different planning groups regarding the customer supply and transmission and distribution for both gas and electric to help articulate how those different futures would lend itself to a portfolio and how we may develop that. We can go to the next slide. So the scenarios that we set up establish a range of energy needs across the gas and electric, and the ISP is based on modeling those assumptions and what the portfolio may look like to serve that load. These are not preferred outcomes. And we really want to highlight that scenarios 2 through 4 require different forms of mandated electrification. This amount of load shifting is unlikely to occur organically, and that's because specifically in 2 and 4, that's really talking about retiring customer appliances before they're ready to be replaced. And I'll talk more details about this in a moment on the next slide, but just wanted to highlight that for today. And as you look at this graphic that is hopefully a little familiar to you at this point, what we're trying to articulate is, again, that bookend concept. You're starting at the reference case with the HP for 1589 and the current trends, and then you're growing that electric demand while you're decreasing the gas demand at the same time. And I'm going to go into more details, so don't worry, but this is just a graphical illustration of that. So we can go to the next slide. We're trying to out a different matrix for you today. We'll see how this one lands and if it's helpful. So the same concept of the scenarios on the prior slide, if you visualize those from the electric impacts and the gas impacts, you can see the references on the left, and then we work our way up that graphic to scenario 4 on the right. Today, we're going to talk about the gas results, which is really impacted by the building electrification row. The large load and EV adoption is an electric system impact. However, in scenarios 2 through 4, where we're looking at getting the building electrification at a pace that brings emissions of both utilities below the utilities' proportional share of the state greenhouse gas emissions, increasing that electric load in those scenarios does change the path of how quickly we reduce the greenhouse gas from a building electrification. And you'll see that in the loads and the results as well, but that's the intention there. So on the left, we're starting with the reference case. This has our current targeted electrification pilots, has a CCA low income. We have our current large load requests. So this does not include large like data centers It's based on whatever is currently signed and agreed upon. And this is something we talked about, I think in July with you guys on the different scenarios and what's incorporated, and then as well as the EV adoption. So we brought that EV load down. That was also discussed last month and the impacts there. And then as we move to the right through the scenarios, we're starting to increase those. So scenario 1 is looking at that interactive effect between a gas and electric customer over the planning horizon and over time, looking at different points in time based on a $3,000 heat pump incentive and their bills. Would a customer, when their appliance meets its end of life and no longer works, would they choose to replace their furnace or purchase the heat pump? And so that's what scenario 1 is representing. You can see that the large load and the EV assumptions stay constant. You move into scenario 2, that's where things start increasing pretty drastically. So scenario 2 is looking at bringing, starting in 2030, electrifying buildings at a pace that brings emissions of both utilities below the utilities' proportional share of the state greenhouse gas emission goals. And so that's, ripping out appliances before they have met their end of life to bring it to that emission line. But large loads and EVs are held constant as the prior 2 scenarios. Scenario 3 is doing the same thing. So it's trying to bring those emissions of both utilities down to that state proportional share of the state's greenhouse gas emission goal. However, it is constrained by equipment failure. So it's saying, yeah, do everything you can to get it, but also don't replace something before it's no longer working. But we're also at the same time increasing the large loads a little bit. So we're adding more large loads to the forecast as well as EV. And then scenario 4 is bringing everything to that combined emission line, including ripping out before failure, as well as increasing large loads and EVs. So when you look at the load demand charts of these scenarios that we discussed in July, you'll see that 2 and 4 are the highest impact on the gas side. Excuse me. And that is why, it's because of that unconstrained building electrification component. Okay, I'm just going to pause for a second and we can keep going.
Yeah, Jen, let's keep going just to keep us on time. I think we're caught up with questions, I believe.
Perfect. Okay, next slide. So in July, we had the opportunity to talk through these demand forecasts for the scenarios, and I just wanted to put them up as a refresher today as we begin to talk through the results. So we have the electric winter peak on the left and the gas winter peak on the right, and you can see based on how I described those scenarios, the gas decreases over time, and highlighting that 2 and 4 come down pretty similarly because of the replacement of equipment before failure. And then you can see that 3 is a little higher, and then scenario 1 is a little bit more modest in comparison to the others. So this peak forecast here on the right for the gas is what is used across the planning teams as we developed the portfolios that would help meet the energy needs based on these demand forecasts and the criteria that we talked about through the scenarios. We can go to the next slide. These are the total results for the gas side. So when we look at the gas portfolio across customer, transmission, distribution, and supply, these are the NPV based on reference and scenario on your screen. So you see references at the bottom and then scenarios 1 through 4 on the top. These costs do not include a few things, and it's important to know that. So they do not include the costs and the benefits associated with the retirement of the gas system, the corresponding electric utility costs, and the cost of electrification, specifically in 2 through 4, where we're electrifying rather rapidly. That is not reflected here, and that's something we'll work to show in the September meeting. And the value of the no-cost allowances is also not incorporated. This only shows the gas portfolio, supply side resources, the social cost of greenhouse gas costs, gas conservation, and gas transmission and distribution. This does include CCA allowance purchases at the ceiling price is another thing. that these are reflected the ceiling price. Right now, the market is at the expected price. So those are just all things to consider as you look at this graphic. And these are based on the modeled assumptions and inputs based on the scenarios that I just talked through. And we're going to dive into each of these sections. I'm just giving you the high level. Here's the total cost, and then we're going to have each group talk to you about their specific results. We can go to the next slide. So using the same approach that we discussed in the May RPAG regarding the reference case, we've translated these costs into illustrative cumulative gas rate impacts by scenario. And it's really important to note that these are illustrative and only based on the hypothetical assumptions that we used as I described those scenarios for you. Again, 2 through 4 would require additional mandated electrification. They also include the CCA ceiling price, which does have an impact on the costs associated in the gas utility, and the current market is at the expected price for that. And these rates do not and should not be interpreted as PSE's expected rate impacts. This is so I have this graphic, and I have the next slide is just zoomed in so you can see the scenario reference in scenario 1 a bit more clearly. So we can go to that slide if it makes sense, just to see the nuances there. Same caveats apply for this one as well. And as I mentioned, when we move into the September meeting, we'll go through the electric scenario results as well, and it'll be really helpful to see the full picture with the gas and the electric system impacts, while also the cost of the electrification as well. That is what I had. I don't know if there's any questions before I hand it over.
Thank you, Jen. Great presentation. There's just one question that I can see from Quinn. Do these costs include the elasticity effects of raising rates?
So the rates were used in the scenario 1 analysis, and that was from the 23 decarbonization study that we have published on our site.
Okay, thank you. And I'm going to go to Eliza. Go ahead, Eliza.
Thank you. I'm sorry, I'm not going to go on video. I'm not feeling that well today, but I did have a question about the previous slide, and just it showed the rate increases starting at 50% or 75%. What does that mean? 75% of what?
Over existing rates today.
Okay, so starts in 20 above existing rates. Okay, it's just hard because it doesn't start at this 0. Okay, thank you.
Yeah, it's true, and it's a high level. It's not intended. It's not down to the granularity, so it's very high level view.
Okay, sorry. Thanks.
No, you're good.
Thank you, Eliza. I hope you feel better. There was a follow-up from Quinn, and I see his hand raised. Quinn, I'm not sure if this is the same question, but are the gas and electric system rate impacts going to be presented together?
Yeah, so we're going to talk about those in September when we have the electric results as well. It was good clarification. Thanks.
Yeah, thanks for that. Quinn, is there a different question you have too?
Yeah, I actually had a follow-up on Eliza's about the presentation, if you go back one slide, of the rate impacts starting with 50%, or like, we'll call that 75, above the current rates. That, so my understanding is that's kind of within, and maybe we're getting a little too far afield of like stuff presented within the general rate case versus like kind of what's being presented here. I'm sort of wondering if those are lining up or what's kind of happening there.
No, these are not intended to be reflective of PSC's expected rate impacts. These are just based on the planning exercise and the modeling within the integrated system plan. So this is different to your point, and is at a higher level at this point and should not be taken that way.
Then, so if these are kind of hypothetical, like what, like how should we be taking this then? Is it just like illustrative that, yeah, if we do all of this, gas rates might increase within like a certain range? Maybe I'm just not, maybe I'm just kind of being confused like if it's like a range of impacts versus like the line looking a bit more like a definitive impact.
Yeah, it's helpful to consider them from a comparative perspective across these scenarios and directional of the different impacts. Again, these scenarios are incorporating assumptions based on the planning requirements in HB 1589, which aren't necessarily the same prices that we're seeing in the market or for the Climate Commitment Act or the resources themselves. So there are a lot of nuances between reality and some of the requirements that we're required to show for the planning process. And this view is one of those requirements.
Great, thanks for those questions, and Jen, for your presentation and for your responses. We're going to go ahead and move on to our next presenter, who's Mark Lenson, the Manager for Development and Evaluation at PSE. And Mark is going to present on the gas scenario results, specifically the customer programs. And again, Mark, I'll monitor the Q&A in the chat, so feel free to focus on your presentation. And we will try to hold questions till the end of Mark's presentation. Go ahead, Mark.
Great, thanks. Can you hear me okay?
Yes.
Great. All right, next slide, please. Again, my name is Mark Lenson. I'm within the Customer Energy Management Group, and so I'll be talking about the customer-focused results from on the gas side today. And as Jen mentioned, we'll do the electric side in September. So today's session, we want to talk about the gas conservation programs, kind of what's comprised, what's part of that, how we built the models and the inputs, and explain some of the results we're seeing as outputs from the modeling. So what we need from you is just to make sure it all makes sense. This isn't, quite the same as what we've been talking about the last, hour or so. And also, if there's any feedback that allows us to kind of refine or provide better explanations of things. So looking forward to that as well. Next slide. So what's included in gas conservation, it's not, it's broken into three categories or market segments. We got residential, commercial, and industrial. On the residential side, things like home weatherization, air sealing, duct sealing, hybrid heat pumps are a part of that too. What you don't see are gas furnaces and gas water heaters. Those used to be part of the assessment and portfolio, no longer allowed via the 1589 language in the law. Commercial, got space and water heat equipment, at least through 2030. Building systems and controls, so that's what's controlling your heating systems or water heating systems or processes. Heat recovery, where you're scavenging heat from some exhaust or waste heat stream and dumping it back into a useful purpose within the building or facility. And then there's commissioning and energy management, kind of the ongoing maintaining and managing your energy use rather than just kind of waiting to see what happens every month or every year. On the industrial side, there's process equipment. Occasionally there's water heating, that's probably a big one. And then you have a couple of the more common ones I mentioned on commercial, which is commercial commissioning and energy management, as well as energy recovery or heat recovery. Within the conservation potential assessment, which is typically done on a 2-year cycle, that's built with a top-down and bottom-up approach is how Cadmus has described it. We get a load forecast that says kind of the upper bounds. You can't generate a model that uses more energy and has more potential than what we forecast to begin with. So that's kind of your top level cap or guardrail, if you will. And then within that, from a bottoms up approach, they use building stock assessment data or building information and end use load information to kind of build up. Well, if I'm capped at, let's say 100, well, what makes up the 100? How many of all these different building end uses, you add them up, you should get up to about 100. And so that's kind of how the main guardrails for the conservation potential assessment works. And we kind of follow that similar process both on the gas side as well as on the electric side. And that's basically used as an input into this modeling process we're talking about today. A parallel effort that's related but is also distinctly parallel and distinct is the target setting and the BCP or biennial conservation plan process. So we have targets through that process where the Conservation Resource Advisory Group, or the CRAG, in odd years, we work with them quite frequently, similar to what you guys are experiencing now on the RPAG, to help drive and refine and finalize target setting for the program cycles. So right now, that would be next year. In 2027, we'll be working heavily with RPAG to finalize the 28-29 plan or program cycle. That gets filed at the end of late next year, and that's kind of the official target setting process for customer programs specifically. Next slide. So in coordination with Cadmus on building the conservation potential assessment, that basically fed into our reference case. One of the things that was a little unique with the reference case this go around for the ISP was trying to blend in kind of an assessment of our program portfolios today, so current offerings, and then blending that with the CPA after a 5-year approach to kind of align with their ramp rates and other things for that portfolio. As I mentioned before, what's in that reference case is a removal of natural gas appliances, so that's like gas furnaces and water heaters for the most part. It also had to accommodate no residential hybrid heat pump measure starting in 2030. I will just call it that when we call it a hybrid heat pump system, like in a residential environment, you're basically adding a new heat pump to an existing or a replacement furnace project. What we found in some studies is that saves about half the gas. So it doesn't take out a majority of the gas use on average. And so that's why we continue to call that a gas savings measure, because the gas furnace still provides about half of the energy use for a particular heating season. Finally, in 2030, commercial gas equipment also goes away as part of the ISP law. And so that had to be accounted for within our reference case as well. So that builds the reference case. And as Jen just went through just moments ago, how we look at the different scenarios are based on that reference case. So we built the reference case, modeled kind of a hybrid program portfolio with the long-term CPA planning process. And kind of at the end of the day, what you're going to see and what the outputs are is kind of like what's left for gas conservation as customers transition away at different rates. Jen already went into all that, but at different rates of electrification, what's left for conservation. And so I think that's what you'll see. But we use the reference case as kind of the starting point for that, and then use this electrification rate to kind of compare and assess, well, what's left, what can we do in the long run from a gas efficiency or gas conservation program perspective as these changes are modeled. Next slide. So what you'll see here is kind of your reference case. That's the purple top line. Goes up a little bit steeply, but as you hit the 2030, that's where that peels off and we start losing some of the opportunities that we maybe take advantage of today. So commercial gas equipment, as well as hybrid heat pumps. And then you see that curve kind of not flatten out, but it definitely gets flatter than the first few years of the profile. And that's basically a description or a result of what I described of like, hey, we can't do as much as we are currently doing now. So you'll see that shift. And what's been interesting is looking at once we've established that, you've got scenarios 1 through 4, and you kind of see these variations of how quickly things peel off for gas conservation, much like the graphs that Jen was just talking about from an overall perspective. So the gas conservation assessment or potential pretty much mimics that, and we basically have variations of how much and what's left. Obviously, in scenarios 2 and 4, things get real quiet on the gas efficiency program front in the early 2040s, as there's a lot less equipment and systems that we can even go after. So that's what you'll see there, where the scenarios 1 and 3 are a little bit of a softer approach to that versus just heavy-handed changes that you see in scenarios 2 and 4. Next slide. Another assessment we're looking at here is comparing the original reference case assessment. So that's what I was just showing on the previous slide, to the benchmark sensitivity. So that's kind of what we sometimes call the optimized case, where the model is now going, hey, I know just pick from this a la carte, if you will, bundles. So we organize the CPA results into 18 different bundles of different cost effectiveness, if you will. So as you go through the selection process from the resource side that Gurvinder will be talking about soon, it's trying to say, okay, well, based on these variables, I'm going to pick this much gas conservation, regardless of your input. This is what we think could be cost effective. One of the interesting elements of this process per the ISP requirements is to use the CCA ceiling price. You saw that on a previous slide that Jen was talking about as well. That kind of puts it's an assessment of looking at the impact of that, but we don't charge customers the CCA ceiling price. So you'll see, you're kind of wondering, why is there such a big gap between the reference case, which is our best guess of what we can do with our programs, and the model saying, I need more, I need more. And so that one of the differences, we still have to dig into this a bit more, but what are some of the other drivers for that? One of them is that customers don't see a CCA ceiling price in their bill. It's more, I think, in the range of mid right now, but they also don't see a social cost of carbon charge, right? That's something we reflect in the value of gas savings, but it's not something that customers see on their bills. So that's one challenging interaction when you talk about trying to model what could be cost effective and assigning value to something when customers don't necessarily see that, or it's not reflected in their own business case. So that's one of those challenges we've had for a while now around the value of gas savings from a modeling perspective, and what's the impact on customers and in their decision making and their utility bills. Okay, next slide. So to continue this comparison, what we're looking at here is kind of the estimated cost of the portfolios over time. So here we're looking at reference versus all the 4 different scenarios. For point of reference, today's or current biennial conservation plan, our budget is about 92 million, so roughly 46 million per year. And what you'll go, wow, that shouldn't you hit those numbers more quickly? Like I said, as we get closer to 2030, you'll see a lot less program spend, if you will, as we lose things we can spend our conservation dollars on. And I think this is kind of reflecting that, where we have still a decent reference case dollar amount or portfolio amounts listed there, but through all the different scenarios, you see a pretty drastic reduction, especially in the out years, of what's left, how much we would spend. Whereas if you're looking at scenarios 2, 3, and 4, it's basically flat between the 2035 and the 2050 range, because there's so little that we could influence from a customer efficiency program perspective. Let's see, I think I've got one more slide and then we can hit some questions. I think we're getting caught up. One more slide, please. Okay, so going back to what I was mentioning earlier about the target setting process. So the ISP has its own established process. We have a parallel established process. So we do a planning cycle every odd year, because that's feeding the subsequent 2-year plan. So we file that late in the odd year. For this current cycle, we would have filed that late in 2025, and now we're operating in 26, 27. There is a connection between the processes. Formally, the IRP would say, hey, here's the number of bundles, and it would help determine the EIA target setting amount. And so now that's been kind of morphed into the ISP process. So there's still that connection despite being completely separate regulatory processes. And as I said earlier, on our planning years, we're meeting with our advisor group, similar to you guys, almost on a monthly basis for much of the year, not the entire year, as we move towards filing of that in, I think, the November timeframe of each odd planning year. It's like I said, it's filed in November, which leads up to the subsequent calendar year launch of that biennial plan. It does include both gas and electric, and also includes some of the costs for demand response. And let's see, typically we get UTC approval of the biennial conservation plan late in that odd year, or very early the following year as we launch the biennium. And so that's it in a nutshell. I've been kind of rambling through here. I didn't see any questions. Are there questions I need to hit?
Mark, thank you for that presentation. We are still playing catch up. So what I'm going to do, there's only one question.
Okay.
It's in the chat, and I'm going to ask you to go ahead and just address it directly in the chat,
Okay,
so that we can play a little bit of catch up.
Okay,
So
no
thank
problem.
you very much for your presentation. We're going to move on to the next presenter, Gurvinder Singh, who's a consulting resource planning analyst with PSE. And Gurvinder is going to present on the gas scenario results and specifically the gas supply. So Gurvinder, it's all yours.
All right, thank you, Hillary. Good afternoon, everybody. This is Gurvinder Singh. I'm with the ISP team. I work on the gas supply portion of the resource plan. And today, well, we can go on to the next slide. So today we'll be presenting you with results or draft results for the scenarios and sensitivities. And this is an informed presentation, but we always look forward to your feedback on whatever we present, and we'll look at how we can incorporate that in the future moving forward. Let's go to the next slide. Okay, before we get into the results, I just wanted to give you a little bit of a summary of the things we've shared with you in the past. These are assumptions, key assumptions that go into our gas portfolio modeling. And we start, the basic assumption is on demand, and we get the demand forecast from our load forecasting team. This ISP, they incorporated the conservation into the demand forecast. So we're getting a load forecast net of demand, net of DSR or conservation. And we call that the embedded DSR forecast. They also use weather data to develop their demand forecast. So we also import the same weather profile into our modeling so that we're consistent with the load forecasting team. The other variable that we use is the gas price, and we purchase that from Wood Mackenzie, which is a consultant. We get their mid, high, and low prices. That's a long-term forecast, and what we do is for the near term, we align it using forward marks data, which is from another outfit, so that we're consistent with some of the other folks in the company that are using the near-term information. As far as the Climate Commitment Act allowance prices, we've been following the guidelines from HB 1589, which says that we should use ceiling prices for our modeling purposes, and that's what we have assumed. And similarly, for the social cost of greenhouse gases, we have instruction from HB 1257 to use the values published by the UTC's website. That's based on the technical document, and use the GDP inflator to adjust the values to nominal prices. Then we also consider existing supply side resources in our portfolio modeling. That's our pipelines, our storages, and we input all of the operational characteristics and costs associated with them into our model. And finally, we have resource alternatives, which is the things that the model will optimize for us and provide some outputs. In this particular analysis for the gas system, we've been looking at pipeline storages mainly. And this process with the resource alternatives is also known as capacity expansion, although as you will see soon, in our case, it was capacity contraction. So that's another way you can optimize your system by reducing it. Go to the next slide. Okay, once we have all those assumptions, they're put into our Plexus gas model, which is a mixed integer linear programming model that has the objective function of minimizing system cost. And so we run all of our scenarios and sensitivities through our model, and we get an output primarily of quantities as well as costs for each of the portfolios and sensitivities. And that's what we'll be presenting to you today. And then one additional step after this is we use all of this information to inform the development of the preferred plan, which is something that we'll be discussing with you at a later RPAG meeting. Okay, go to the next slide. So this is the reference case, and we have presented you with gas supply costs in a draft version back in May. And we're updating this slide to add row 3, which is the August update. And what you see here is the portfolio costs for a gas system. And from the May iteration till now, you will notice that the portfolio costs have gone down. And that's primarily a factor of us not including the consigned allowances or the no-cost allowances as part of the portfolio cost this time around. And we also made one other adjustment since May. We've been allowing the storage to be evaluated as a resource alternative in the model. So if there's any, the model has the option of looking at both pipeline capacity and storage capacity to optimize the system to meet the demand. So those are two factors that have contributed to this lower cost. The consigned allowance cost is just, it's an artifact of just not including it here, but that cost is there, it's just in a different bucket. All right, next slide. We've presented this result before in May as well. This is called the resource balance diagram. It shows our demand, which is the dashed line on the top, and the bars are the supply side resources, both the pipeline and the storages, which are used to serve that demand. And as you can see, the bars meet the demand, so that means we're able to serve that demand. And we're not short, and neither are we long, so that's why it's optimized. The model is able to consider unused resources so that it can serve the load. So we're not showing the unused portion of the pipeline, for example, in here. So what's different from the May slide to this slide is very little. It's just in 2050, we have a little bit of the storage is unused, and we keep a little bit more of the pipeline. Because as I mentioned before, since May, we have allowed the model to be able to optimize around the storage as well. So it did optimize it in this reference case, just in 2050, and by a very small amount. Okay, next slide. So we have looked at these scenarios before. Jen went over them in her presentation. These are 4 scenarios that have to do with electrification that we considered in our analysis. And I would call the scenario 1 as being a customer choice, market-driven, incentive-based electrification. And scenarios 2, 3, and 4 are electrification which are mandated. They're policy-driven, and they're increasing in order of, I guess, not complexity, but in depth. We're doing more electrification as you move from scenario 1 down to 4. 2 and 4 are essentially the extreme cases. They're early replacements of gas equipment with an electric appliance. So we are being pretty aggressive in those 2 scenarios. Scenario 1 and 2 are replacements at the end of life, except scenario 1, the customer makes a choice based on incentives available to them. In scenario 3, the replacement is done as a policy. So all the other variables like gas prices, CCA price, and social cost of greenhouse gas were maintain the same as the reference case. And then we'll next talk about the results for these scenarios. Go to the next slide. So this is a snapshot in 2035 of our supply side resource, what we call bills. And our scale is negative here, so we're not building things, we're actually ending up with unused portions of our supply system. And what this shows in 2035 is reference case and scenario number 1. We have unused pipeline, that's the orange bar. And in the extreme electrification, the mandated electrification scenario 2, 3, and 4, we have quite a bit of unused pipeline proportional to the amount of electrification that's happening in the system. The green bars are on the reference in scenario 1 are SWAR, which is a peaker plant that we have, which is brought online in 2030. And in these two scenarios, it is used and it's still part of the system, whereas in the electrification case, it's not a resource that's used. Go to the next slide. So this is a look at what happens in 2050 to our resource bills. More unused pipeline on reference case and scenario 1, with a little bit of unused storage towards the end. But when you look at the mandated electrification, especially scenarios 2 and 4, all of our pipeline is unused, and pretty much all of our gas, what we call gas peakers and storage facilities, are unused. Scenario 3 has a little bit of pipeline that's in use, similar and storage in use. However, for all intents and purposes, it's also most of it is unused. So we would expect that we're looking at some very extreme electrification scenarios where pretty much all of the gas demand is gone, and so this reflects that result. Go to the next slide. So one more output that we get from the portfolio analysis is the portfolio costs. And this slide is showing the output of portfolio costs for the scenarios in comparison to our reference case. And of course, they're declining, but there's a bunch of caveats with these numbers. They don't include a lot of other costs, which are relevant and important. And I'll just point them out, and I will also say that these things will be included and covered a little bit more in detail when we do the combined look in September for the gas and electric system. So we don't have, for example, electrification conversion costs for the electrification scenarios. That is the cost associated with the actual replacement of the equipment, including any upgrades to like the electrical panels. We don't have the conservation costs in here. There is conservation in all of these scenarios as well as electrification. So that cost is not in here. We don't have perhaps the benefit of a transmission distribution system, gas transmission distribution system in here. And I think as we mentioned before, we're not looking at any of the costs associated with retirements or what I may call the unused supply side assets. So that is a whole different accounting process that was not part of this analysis. And it's important, but I want you to be aware that it's not part of this analysis. Okay, go to the next slide. So this is a picture of the emissions by scenario, and we can see that the more electrification you represent in a scenario, the less the emissions are. And this is a look only at the gas system. And just like the costs, I think it's important for us to be able to look at a combined picture of what the emissions will look like, net emissions will look like once we take into consideration impacts on the electric system. And that we'll be able to present at the September RPAG. I will make a couple of notes that we have existing RNG programs in place. These are the volunteer programs, which help to reduce some of the emissions, and they're reflected in these emissions. What we have not reflected is transport customers with emissions less than 25,000 a year. As you know, that's a requirement under CCA, but it's just not in this particular slide. Okay, go to the next. So the key takeaways from our scenario analysis, well, in all of these, including the reference case, our load is declining. And as the load declines, we need less supply side resources. So in all of these cases, we're seeing some level of unused pipeline. And in the extreme mandated electrification scenarios, we're also seeing storage as being largely unused, especially in scenarios 2 and 4, it's completely unused by the end of the study. So with the reference scenario and the scenario 1, only the pipeline is affected and storages are intact. We had one contract for Plymouth LNG to be renewed. It was cost effective. It was renewed in the model. Not so much in the extreme electrification scenarios. Okay, go to the next slide. Okay, I can pause here because we're going to pivot to scenarios. I'll leave it to Hillary to decide where we are with time. But we presented these scenario results, and we're going to talk about some sensitivities here.
Yeah, Gurvinder, I'm going to ask you to keep going. Megan, if you could just hold your question, we'll see if we have time for questions. Maybe post your question in the chat and we'll see if we can get it addressed there. Thank you for your patience, but we'll pivot back. Keep going, Gurvinder. Thank you.
Okay, thank you. So we also did sensitivities. A sensitivity is basically a change in one of those key assumptions from the reference scenario, and we're able to look at the effect of that particular variable on the reference, the reference portfolio. Let's go to the next slide. So these are the sensitivities that we looked at on the gas supply system. We had one, which is the benchmark DSR, demand side resource, something that Mark talked about earlier. He looked at the results of those. We did in here. Basically, we offered the model the opportunity to optimize or select the level of conservation that would minimize the cost on the system. The other sensitivities, all of them except for the other RNG one there, had to do with cost in the system, and 4 of them were related to the carbon adders, CCA prices, as well as social cost of greenhouse gas. And we had 2 that looked at impact of gas prices on our portfolios. The RNG was a sensitivity where we looked at sourcing RNG from a wider or larger geographic footprint. We looked at sourcing it from outside of Washington. And we did that in the form of RTCs, which are renewable thermal credits, which we could purchase and use those in conjunction with our conventional gas to be able to green up the gas and serve our customers with no impact on emissions. So that was what that sensitivity was. All right, we'll go to the next slide. So these are the results, summary results of the sensitivities. The first one there is the RNG, North America source RNG. And the numbers you can see in there are the same as the reference, because in that particular case, we offered the RTCs as a resource alternative in the reference scenario. We allowed the model to be able to choose the RTCs if they were cost effective, and it did not choose those. The RTC prices are pretty high. We utilized RTC prices that were reflected in other IRPs in the region here. Obtaining this information is very difficult. RTC prices are not readily available. It's a very illiquid market. And so we did want to reflect the effects of what this might do if we buy RNG, but just want to caveat that this is a very hard to get information, and we did what we could based on what others have done in the region, and I think we will continue to tweak this as we move forward in the future, as more information comes along, as more projects are done, and the market develops further. But for now, it's not cost effective. The benchmark DSR, the model did pick more of it, and that reduced emissions a little bit. It also reduced reliance on pipeline and had a lower portfolio cost. The other sensitivities with the CCA all resulted in lower portfolio costs, and perhaps that shows the impact of those policies on our portfolio when you compare it to the reference scenario. And we didn't see too much of an impact on the emissions profile with the changes in the CCA prices. And that's partly because we didn't have any other options in the model. We just changed the prices. So if we had some other, let's say, resources, alternatives that could reduce emissions, for example, if we had done conservation or something associated, co-optimized with those prices, we may have seen a shift in the emissions based on how much demand was reduced by the amount of conservation was being selected. But we did not do that, so we have a consistent level of emissions profile for those, and what information we do get is the portfolio costs. And we can see that the portfolio costs contributes, the CCA costs contribute significantly to the portfolio costs. Similarly, we looked at prices on the gas, the high and the low. There was some impact, not as much on the portfolio costs. All right, go to the next slide. I went over some of the key takeaways on the previous slide. This is a graphical representation of those results. You can see that the impact of on the portfolio cost for the policy type measures, which are the CCA and social cost of greenhouse gases, are significant. As far as pipeline usage is concerned, it's primarily driven by demand, and because we have one sensitivity that affects the demand, which is the DSR, we had more pipeline which was unused in 2050 from that sensitivity. And I think that's it. Yeah, I can answer any questions.
Great. Thank you, Gurvinder. We actually have been having questions answered in the chat, so I think we're good. There is one question from Quinn that is going to be addressed in the feedback report. So thank you for that question on RNG, Quinn, and it'll be addressed in the feedback report. I'm just kind of skimming to see there's others. So we do have about a minute. We're pretty much caught up, which is fantastic. Thank you for doing a timely presentation, Gurvinder. We are running a little over. I think we're caught up on questions. Somebody correct me if I'm wrong. a lot going on here, but I think we're good. So with
Thank you.
that, yeah, thank you so much for that presentation, Gurvinder. With that, we're going to go ahead to our last segment before we do public input. And this is Nisi Weatherby, who's the manager of Gas System Integrity Program at PSE. She's going to present on the scenario results and specifically the gas delivery system. So Nisi?
Yes, next slide. So the purpose of today's meeting is to inform you on the results of the delivery system scenario and analysis as well as the sensitivities. We'll be looking for clarifying questions, thoughts, and feedback on both the scenario and sensitivity results. We'll use your feedback as time allows to inform additional sensitivities. Next slide. When we think about the gas delivery system's role in the integrated system plan, it's to ensure safe, reliable natural gas while managing a potential large transition. When I realized as I was preparing these slides and thinking about last month's electrification potential assessment analysis, that I wanted to make sure that we did a quick review on the reference case and what makes up the portfolio before I jump into the results. Some of the work is highly predictable. We know what we need and where it is located and when we need it. An example of that is the federal requirement to reconfirm the maximum allowable operating pressure, or MAOP, on 12 miles of transmission pipeline and 15 stations, with a goal of 50% by 2028 and 100% by 2035. On these, we know the needs, even if we don't know how we're going to achieve them, and we know where they're located. But we also have work where we know the type of issue we're going to encounter, but we don't know where it will occur. A good example of this is our shallow pipe program. Through routine operations, construction observations, and field inspections, employees may identify pipe that no longer has the required depth of cover. If the depth is less than 12 inches, it's viewed as a higher risk, and we move to work to remediate it, preferably within the year, not to exceed 2. These conditions will continue to be discovered over time, but we can't predict where on the system they're going to be found. And then the third category are kind of an emergent work. These are issues that arise unexpectedly and require a response when they occur. Examples could include an odor investigation or a gas leak response, but they also include things like customer encroachments, and that's where a customer may build a deck or even a structure over our gas meter, and we need to do something to be able to operate and maintain it. We can't predict when these events will happen, but we know they are part of operating a gas utility, and they have to be accounted for in our analysis. The planning horizon for this analysis is 28 to 2050, and the primary outputs are cost. That are the costs that are needed to operate and maintain the system. In the next couple of slides, I'm going to explain how we identify risk on the system and how we look and evaluate potential solutions. And then later in the presentation, when we discuss the scenario and sensitivity analysis, you'll see the investments grouped by their primary objective. Next slide. So I want to spend a few minutes on integrity management and how PSE identifies and manages risk on the gas system. In 2002, the federal government established the Transmission Integrity Management Program, or TIMP, driven primarily by concerns of safety on high-pressure gas transmission pipelines and the potential consequences of failure in populated areas. In 2011, the Distribution Integrity Management Program was established in response to industry-wide trends involving distribution leaks, excavation damage, corrosion, and aging infrastructure. The program requires operators to understand the system risk, implement targeted mitigation measures, and continuously improve safety performance through a risk-based framework. In addition, The concept of a pipeline safety management system gained support following the 2010 San Bruno pipeline accident. The NTSB, or National Transportation Safety Board, strongly encouraged operators to adopt the safety management principles to not only establish the processes that are in DIMP and TIMP, but to reinforce the culture. Together, these programs provide the framework that PSE uses to identify, monitor, and proactively address risk across the gas system. They establish the rules, expectations, and best practices on how to keep the system safe. In practice, every year PSE evaluates system performance by looking at leak causes, field identified hazard, operating experience, emerging trends. We review significant events that are occurring elsewhere in the industry and see if we have similar type things on the system that we need to address. The risks are then evaluated by the program area and prioritized based on likelihood and consequence. And once they are prioritized, then we come up with our mitigation strategies, and we'll talk about that in a minute. Finally, the program effectiveness is routinely reviewed by both PSE, but also by the WUTC pipeline safety staff to ensure that we continue to achieve the intended outcomes. Next slide. The integrity risks I just discussed are a good example of what we would define as a system need, while the actions we would take to address those risks would be our potential solutions. PSE's planning process for both the gas and electric systems begin with identifying and analyzing system needs, evaluating available options, and selecting the most effective solution. A need is defined as anything that could impact PSE's ability to operate the system safely and reliably. In addition to the integrity-related needs also can be driven by new federal or state requirements, changing customer demand, or the system's ability to reliably deliver the natural gas. As we evaluate options to address those needs, we consider both pipeline and non-pipeline alternatives. One option could be to monitor the situation and collect data. An example for peak demand concerns is this could include installing temporary pressure recording equipment to better understand the winter performance. For integrity concerns, we might do additional leak surveys, patrols, or inspections to better understand the condition or the threat, or to make sure it's not getting worse. The next category is kind of operation and maintenance activities. This would be on a peak demand where we might do a field activity where we inject compressed natural gas into the system to support the demand. Or, and on the O&M, it could be routine wrapping of pipe, painting of facilities. There's a lot of repair capabilities that are out there that we use with the idea of preventing deterioration and extending the asset life. Then we get our customer-sided non-pipeline alternatives, depending on the need. That could be reducing the peak demand in a specific area, or it could be transitioning a few customers away from the natural gas service so we can retire and eliminate the risk. And then as we think about the capital solutions, these can range from a small capital repair, a like-for-like replacement, to an existing asset, a smaller system reconfiguration that avoids a larger investment, or even, or it could be a larger pipeline replacement or reinforcement project that increases the system capacity to better support that demand. Hybrid options are often deployed. We normally don't just choose one. We may do a combination, but the objective is always the same: to identify the solution that best addresses the system need while balancing safety, reliability, cost, and long-term planning considerations. Next slide. Now that we've gone through some of the background on keeping the system safe and reliable, let's talk about the reference case in the study. So for this work, we've grouped it in 3 categories: the customer requested and public projects, reliability and resiliency, and customer and public safety. Customer requested and public projects. So the driver here is people are coming to PSE and asking us to do something. The best example would be a jurisdiction doing a road widening project. They'll approach PSE with their tentative plans. PSE works with them on how to minimize the conflicts. And then if there are needs for us to move our infrastructure to support that effort, we will do that. When we talk about reliability and resiliency, this is really about getting gas from when we take ownership of it at the city gate to the customer end use in all conditions. And customer and public safety, as we talked about earlier, those are kind of going to be my emergent needs to operate and maintain the system, and then there might be cases where I look at assets and proactively do activities in order to prevent integrity risk in the future. And an example of that would have been what we discussed last time when we talked about the DuPont projects. A couple of things I want you to kind of walk away before we go into the slide where we show the amount of investments over the reference case. The first one is that this is a dynamic system. So if I were you, I might look at the reliability and resiliency bucket and go, okay, well, those probably are pretty steady. And for the most part, they are. But I would then say, well, last year we had an incident where, not an incident, but we found a supply line, one of our high pressure pipelines, that we didn't like the condition of it. And so we needed to make the decision of, were we going to retire that pipeline? Were we going to replace it? Or, and what were our options that we wanted to do? The pipeline happened to be on top of a bridge. So we decided that we would go ahead and retire the pipeline. But what it did was it caused a constrained area in a section that we needed to then go reinforce, make sure we had the right mitigation plans for it, and do some smaller projects to bring that up to speed. It worked, it was the decision, but those are just the kind of things that happen. And so I think my takeaway I want you to have is, even though we're going to give you our best plan, it may change as we learn more and as the system changes. Approximately 50% of the system needs from 2028 to 2030 are known today. The remainder will emerge over time through the different work that we just discussed. And one thing, as we look in the reference case, the planning uncertainty is going to increase as the horizon extends. Next slide. So let's look at the reference case. So if you look at 28, 29 through 33, you will notice that the categories are bouncing all around. You'll see some are big, some are small. That's because that's where my known projects are. The large drop from 2032 to 2033 is because I don't have any pipeline MAOP reconfirmation projects in there, and because my DuPont replacement program is completed. In 2034, the reference case goes up because of an MAOP reconfirmation project, and then the rest are just kind of trended over time and go up with inflation. So with that in mind, so before I move on, are there any questions just on how we built the reference case and what's included before I jump into the results of the analysis of the scenarios?
Thanks, Nisi. I'll pop in and help with the Q&A. We're taking a little pause because Nisi has a long presentation. So time for Q&A. Megan, go ahead.
Yeah, thanks. I was just wondering if you could elaborate a bit on the difference between the customer and public safety investments category and the delivery system reliability and resiliency category. It just seems like there might be some crossover there. So I was wondering where you draw the line. Thanks.
Yeah, so I think where I draw the line is the resiliency is really about getting gas to the customers. So if I'm not concerned about a public safety, then it's just about on a cold day, am I able to supply the gas to the customers when they need it? But it's really it's a supply focus. Whereas where we draw the line with integrity is where we're concerned that we could have something bad happen to either the public or to the safety or to the system. So where we're looking at public safety, we really are focused on that integrity and safety concerns, where I think everything that's in the reliability is more just around, we're not concerned about damage, we're concerned just about getting the supply to the customer. Does that make sense?
Yeah, thank you.
Thanks for that question, Megan, and your response, Nisi. Are there any other questions for Nisi before she continues? Katie.
Yeah, thanks. I maybe in the feedback report, it would be helpful to see some examples under those three umbrellas to get a better understanding of sort of how you categorize. Thank you.
Thanks, Katie. So a request for examples, I heard. Any other questions? Nisi, I'm not seeing any in the chat and nobody's hand is raised, so I think you can keep going.
Yeah, so as you heard from Gurvinder, or from when Jen did her presentation, for the gas system, scenarios 2, 3, and 4, especially scenario 2 and 4, really kind of shows the end of the gas system ending somewhere between 2041, 2042, 2043, with the exception of a few industrial customers. And then scenario 3, you end up with a little over 100,000 customers on the system. So as we're looking at the investments over time, with the reference case, we assume that we have a decline in usage, but we have the same number of customers. So what you saw was this trend, and it was inflation. When we go to scenario 1, you have about a 25% reduction in customers. Well, that reduces the spend, but not by 25%. It's based on the timing, and you still have to maintain and operate the assets. For scenario 2, 3, and 4, it becomes a math problem. Of course, if you have less customers, and then you have less pipe to maintain after that, then your investments go down at some ratio as it relates. But that's just part of the picture. Next slide. Because on the other hand, there's still field activities that are needed to safely shut down the system. And so if I'm looking at the reference case today, I might disconnect, and I'm focused on services for this, but there would be other assets that would need to also be shut down. But right now, I probably retire between 500 and 750 services a year. In scenario 1, with the 25% reduction, that jumps to 200,000 over the course of this the study period. And why that's important is every service that is retired, we have to go out and physically disconnect it from the main or from the source of the gas, and we need to remove the riser, the meter, those equipment, so that we can properly deactivate the system and avert any safety issues. And scenarios 2 and 4, essentially over the next 22 years, you would be needing to shut that down. And those are just things we're going to have to do. There's going to be field activity associated with it. That is something we need to start thinking about. In the next slide, and so that's kind of where the sensitivity analysis is. When we look at the scenario, or the scenarios are, next slide for the sensitivities. When we did the sensitivities, I'm sure you all remember, and I'm just joking when I say that, Last June, when we talked to you, we talked about doing some sensitivities. One was on renewable fuel. And the idea there was that a lot of the fuel where we right now is based on RECs, or we're getting the credit for it. It's adjacent to our system, but it's not running through our pipes. So we did the analysis of, well, what happens if we run it through our pipes? We found about 8 additional needs for about $3 million. So what that tells me is that I'm probably pretty safe with my reliability part, or getting gas to customers. But if I have opportunities to inject renewable natural gas into our system, I need to pay attention to these 8 locations, and those might be areas where we would pursue a non-pipeline alternative. The second sensitivity is just one that we felt like we needed to add around customer growth. And the reason we want that in here is all of the scenarios are so focused on what happens if the system shuts down, where we have still seen growth year over year, even last year. So in this particular scenario or sensitivity, we had a 5% growth between now and 2035. And what it highlighted was about 14 additional needs at about $12 million. Once again, that kind of emphasized to us that the local growth would drive constraints, but we don't have a system-wide issue. And once again, no actions taken. They're not new needs that we would identify, but they are things that impacts that are going to be concentrated, and we would just need to monitor and understand what's going on there. And there may be some opportunities at that point. And then we get to the third one, and the assumption is a peanut butter spread. And I was talking to some of the folks on my team, and they're like, what do you mean by a peanut butter spread? But the idea there is that the electrification is evenly distributed. Everyone is just kind of leaving at the same rate, no matter where you are in the system. But the question here is, hey, if I could direct it, could I impact non-pipeline alternatives? And so for this particular case, we leveraged scenario 1 instead of the reference case. The other 2 were based off the reference case. And I do have the ability to scope down 2 projects that result in about $20 million if I can direct where that occurs. Now, what that means for me is, as we're starting to look at our action plans and where we want to go in the preferred portfolio, those would be projects that I want to evaluate more and see if there's some way that we could potentially do that, especially for those that are a little further out. The one thing we weren't able to quantify is, and you might go, well, wait a minute, Nisi, what about all those DuPont projects? We weren't able to quantify or figure out how to quantify what that would look like, but we would assume that we would have a higher migration of those that we could retire without having to offer incentives. And then some that we had said we didn't think were viable may become opportunities. And we would just have to look at that over time, but that's something we just need to be set up to make sure we can monitor. Next slide. So then in summary, as with declining customer counts and usage, and maybe an increase in retirements, our focus still remains on safety compliance and making sure the customers that are on the system have that reliable natural gas. My key takeaways on the system reliability are my needs that I have right now, that we have identified projects to address, are still there, but I really don't have new ones as the system goes, even in my sensitivities where I had some changes. The only thing that might cause an increase in my system reliability would be one of those customer and public safety type events that then may trigger that as an effect. My customer requested in public improvement work. Over time, I would see my customer requested work probably go down, but as long as I have assets, I would still have a small portion of the public improvement. And it's still driven by the amount of assets I have in the field. And with customer and public safety, you're always going to have a portion of that until the system is retired. Scenarios 2 and 4, as they kind of decline, you have less opportunities for those proactive replacement projects. And we think that the targeted electrification opportunities are probably more relevant in the reference case in scenario 1. And then, as I discussed, the asset retirement and decommissioning, that is just something we need to be thinking about and preparing for because it will scale much differently than where we are today. Any questions or concerns? That's the end of my presentation, Hillary.
Thank you very much, Nisi. That was a lot of information, and we have quite a bit of time for questions for Nisi, which is nice. Before we move into the final segment of our agenda, which is public input and public comment opportunity and next steps. So if anybody has questions for Nisi on her presentation, I know we've taken a couple already. Please post them in the chat, raise a real or virtual hand, and we will call on you. Members of the RPAG, I'm going to give them a few seconds here, Nisi, to see if anything comes in. I know people have been hanging in there for a long meeting today, which we really appreciate. We didn't take a break, so I have a feeling we're hitting a meeting saturation zone, which happens in long meetings like this. Any questions for Nisi? Or comments? Nisi, I'm not seeing anything.
Well, we will make sure we get those descriptions of what's in those categories into the feedback report with some examples.
Great, thank you. Are there any other questions or comments people want to make since we have a little bit of extra time here? All right, I think people have hit their wall. So why don't we go ahead and pivot to the final segment of our agenda, which is next steps as well as our public comment opportunity. So go ahead and go to the next slide, please. No, next slide, please. So I wanted to first take a few minutes just to make sure everybody understands kind of what's happening post-meeting, including the feedback process, and then we will pivot to the public comment opportunity. This is how the feedback process works. This is a refresher and a reminder for a lot of people, but for some people it might be new, so I want to make sure everyone understands. 1 week prior to RPAG meetings, the feedback window for that meeting begins. 3 to 5 days prior to the meeting, PSE posts the agenda and the slide deck on their website. Day of meeting today, PSE engages with the RPAG for feedback and facilitates a public comment opportunity. A week from the meeting, which in this case is September 2nd, so next Tuesday, September 2nd, the feedback window for this RPAG meeting will close. And then 4 weeks from today, PSE will post the meeting summary and feedback report on their website. So that's how that works. Let's go to the next slide real quick. Oh yeah, we'll go through the upcoming activities and then I have a couple other announcements. So I already noted that September 2nd is the closing date for the feedback form. September 23rd is our next RPAG meeting. It's going to be 3 hours as well. So please note, since there's a lot of information coming right now, our meetings are going to be 3 hours unless otherwise noted. That meeting is going to really build on the information in this meeting, but make the connection with the gas supply and the electric system. We started talking about that a little bit today, but that's going to be the connection between the two meetings. And then there's a bunch of tentative dates for the October, November, December, and a January drop-in session. So just make a note of those. Those are tentative at the moment. I'm going to ask Jack to share slide 31 again. I want for RPAG members, as you're thinking about the feedback that PSE is specifically looking for during, I believe it was, let me see if I get this right. During Elizabeth's presentation, she had a couple specific questions and we didn't have a chance to get to them. So Jack, if you could take us back to slide 31. Real quick. There were a couple specific questions that Elizabeth had. First, on the sensitivity coverage, are the emerging technology sensitivities capturing your feedback? If not, what are we missing? And then on the portfolio combinations, are we missing an emerging technology combination that would be critical to inform a preferred portfolio? If you could really keep these questions in mind as you're looking at the feedback form and provide any input that you might have on these two questions, PSE would really appreciate it. So Quinn, I see your hand up. Go ahead.
Yeah, I was wondering, is the RPAG drop-in session going to be limited to just RPAG members, or will it be opened up to the public as well?
Quinn, I don't have an answer on that, so I'm gonna do a little back channel chat with PSE staff and we'll circle back on that question. Thanks for that question. All right, Jack, you can go ahead back to our normal spot in the slide deck. Thank you for doing that for me. Which should be slide, let's see if I can read this, 685. I think it's slide 85. So give Jack a second to catch us up. While Jack is doing that, I wanted to announce to RPAG members that following this meeting, there's going to be an email that goes out asking for you to fill out a meeting poll if you want to do this. I'm hoping to have 15-minute meet and greet sessions with RPAG members. You know, I'm relatively new to the RPAG. This is my 4th meeting. And I haven't had a chance to get to know RPAG members. I usually like to do that when I'm facilitating long-term processes like this, and it really just helps with kind of the dynamic and the flow of things. So if you would like to take advantage of a 15-minute meet and greet session with me, please fill out the meeting poll that will come out after the meeting. So I just wanted to announce that. Also, on this contact us form, there are many, many ways to contact PSE. I'm just going to quickly scroll through them. There's this email address here. There's this contact form. There's the phone number. You can subscribe to the email list and get a lot of updates. And you can also just find everything at the website, which is cleanenergyplan.pse.com. So those are all the different ways that you can engage with PSE moving forward. And with that, I'm just going to quickly check my cheat sheet and make sure I got everything. Before we go to the public comment period, just a few things. Sam has posted the end of meeting poll in the chat, so we really encourage everybody to fill out the poll, give us some feedback on this meeting. And that is all I have for now. So with that, I see a question from Dennis. Since we have some time, I'm going to go ahead and let Dennis's question come forward. Portfolio combination says PSE looked at combining solar with large footprint battery storage facilities. Okay, you know what, Dennis, if you don't mind, we're going to take that question offline. Thank you for that question. I appreciate it. But we'll take it offline and get it addressed there. So with that, let's move into the public comment period. Next slide, please. All right, I have just a few things I need to go over with this. So at this point in the meeting, we ask members of the public, so not members of the RPAG, but members of the public, to raise their hand so we can get a sense of how many people would like to provide public comment today. So I'm going to give everybody a second to do that. Don, I see your hand raised, so I've got you noted right here. Are there any other members of the public who would like to raise a virtual hand? I'm just looking. Okay, I see Mark Road. Hopefully I am pronouncing your last name correctly, Mark. Mark Road has his hand raised. Are there others? Just give it a couple seconds here to see if anybody else would like a chance to speak. Okay, I just see Don and Mark. So with that, we're gonna keep going. Kara, I see you came on screen. Would you like to share a word?
No, sorry, I was just coming on camera for public comment.
Sorry, my bad, Kara. Okay, so we have PSE staff coming online to answer questions. Next slide, I'm going to just quickly go through a few other items on how the public comment will work. I've already noted to raise your hand if you'd like to speak. Each participant gets 3 minutes each. There's going to be a little clock up just to give you a little visual reminder of where you are in your 3 minutes. We ask that public comments focus on the topics of today's session. And we also ask that you keep your remarks respectful. No personal attacks, please. So with that, I'm going to go ahead and ask Jack to put up the 3-minute clock. And Sam, I believe you're the one that's going to elevate both Don and Mark to participants so that they could speak. Don, I'm going to call on you first. Jack, as soon as Don starts talking, you can go ahead and start the clock. And this always takes a second to change the status of participants to speakers, so we'll give it a minute here.
Oh, I'm available when you are.
There you are. Okay, great. Go ahead, Don.
Sorry about that. Okay, I'm Don Marsh, chair of the Washington Clean Energy Coalition. I have 2 objections today. First, slide 24 calls reference case B our starting point for further analysis. That is precisely our concern. Every sensitivity PSE runs is a variation on a gas-heavy portfolio. Change one assumption at a time, and you learn how that portfolio responds. You do not discover a different one. It is like designing an electric car by starting with a gas car and swapping one part at a time. You would conclude an EV is too awkward and expensive to build, and you would be wrong. Your own results today make this point. Slide 26 shows that when peakers are limited, long duration storage gets selected and total builds go down. Your geothermal sensitivity reduced portfolio NPV by $2.1 billion. But no sensitivity shows what these technologies might do in tandem with other clean solutions and high electrification. Slide 31 asks whether you are missing a combination critical to a preferred portfolio. Yes! The missing case is a clean sheet portfolio built around iron air storage, geothermal, virtual power plants, and full electrification of the gas system. We want that portfolio to be evaluated on its own terms, not as a deviation from reference case B. On June 19th, the coalition submitted a 20-page analysis indicating such a portfolio may be achievable at costs similar to or below PSE's reference case. We asked explicitly that it be included in the feedback report. So that brings me to the second problem. PSE told us our analysis would be valuable for ISP modeling. It then appeared nowhere in the feedback report for over 2 months. When we asked why, PSE said it would be premature to comment on our document's accuracy, validity, or reasonableness. We never asked PSE to endorse our analysis. We asked that it be recorded. If substantive feedback can be left out of the record until PSE is ready to evaluate it, the feedback process is broken. Members of our coalition have served on PSE advisory groups for more than 10 years. We are not raising this casually. So, 3 requests. First, acknowledge our June 19th analysis in the feedback report and address the 9 questions we posed on pages 16 and 17. Second, state whether PSE will model at least one clean sheet portfolio rather than only sensitivities on reference case B. Third, yesterday we submitted a detailed set of questions on cost, capacity, and availability assumptions. Publish these questions and your responses in the feedback report for this meeting. If necessary, we will raise our questions in the Commission's review of the ISP, but we would much rather resolve them here. Thank you very much.
Thank you for your comments, Don. We are going to move on to Mark Road. Mark, you can go ahead and come on screen and turn on your audio. And Jack will start the clock as soon as you start talking. Mark, are you on?
I am now.
Oh, there you are. Okay, go ahead, Mark.
I was under the impression there'd be a response, but apparently not. We're just asking questions, and then later the staff can respond to them in some kind of form.
Yeah, Mark, thanks for that clarification. During the public feedback session, we take comments or questions, and then PSE staff will respond to them in the feedback report.
Got it.
So
Okay.
there are live responses in this session.
Okay. Simply a concern. I'm representing myself, not an agency or group. It looks like for the gas peakers and the draft scenarios, I'm wondering if it's possible to identify the health and environmental cost of those resources rather than just their direct and capital costs. And I'm wondering if you could somehow identify an actual cost per dollar or cost per megawatt in terms of social and the added cost for gas peakers in the draft scenarios. I'm also concerned that it looks like it takes you at least 9 years for a new technology to become available. It looks like you're walking into the future, looking backward, and you're looking backward a long ways and aren't able to utilize things that we need now. Yeah, thank you.
Thank you for those comments, Mark, and for clarifying that your comments and questions as well will be addressed in the feedback report. So really appreciate you coming. And with that, I don't see any other questions or comments that people want to make in the public. So I am going to go ahead and just do my own thank you for everybody for hanging in there with us today. There was a lot of really important information that was shared. I want to thank all the PSE staff that worked hard on their presentations and shared it very articulately. Thank you, RPAG members, for asking fantastic questions and for being patient as we kind of navigated how to address all the questions in real time. And those that did not get addressed, again, will be addressed in the feedback report. So thank you for your patience on that. And thank you to my team, Jack and Sam, who are working madly behind the scene to make sure all the technology worked and the presentation was being shared and all of that. So with that, I'm going to hand it over to Kara Durbin, who is going to close out the meeting.
Thanks, Hillary. Well, you covered it well in thanking everyone for the dialogue we had today, but I'd like to echo that as well. As I mentioned at the outset, this is one of 2 meetings that we have to talk about results. So we've gotten the first part covered today. We expect that you may have more questions and comments that'll come in through the next feedback report. You should get the feedback report from our last meeting really soon, so look for that. And we'll look forward to continuing the conversation in September, picking up the electric scenarios and the remaining costs and impacts, and kind of looking at both the electric and gas results together. So really appreciate you hanging in with us for a 3-hour meeting. It's possible that our September meeting may be this long as well. We have a lot to cover, but we just really appreciate your engagement, your questions, and making time for us. So thank you very much and have a good afternoon.